The global air filtration industry has a reputation for being rather parochial and rather resistant to change. Nevertheless, a very significant development has happened in recent weeks. A new standard has been introduced by the ISO organisation for the testing and the classification of air filters used in general ventilation systems. The reference for this standard is ISO 16890 or 16890. Of great significance is the fact that this standard has global applicability, and as if to reinforce that point, the decision making was 100% voted positive by all countries around the world. Until now, there was no such global standard. In America, the ASHRAE 52.2 standard dominated. In Europe, EN 779 was dominant. And in Asia and the Middle East, both standards operated side by side. And in fact, there were other standards for individual countries, such as Japan and China, which are also in use. With the new standard comes important benefits for specifiers and users of air filters, together with the global air filtration manufacturing industry. The standard recognises that air filters enhance air quality and therefore benefit human health. The standard is more intuitive. Both the filter testing procedure and the classification system are much more aligned with real-world pollution than existing standards. The standard is globally applicable, and this will eliminate confusion and also invalid attempts to compare results between existing different standards. The global applicability will also remove a barrier to trade. In today's corporate global world, it's not unusual for a major construction project, such as an airport, that the engineers are sitting in one country, the constructor is based in another country, and the airport itself is built in a third country. The standard will provide a level playing field for the air filter manufacturing industry. It'll be easier to compare products on a level basis and make proper comparisons. In my opinion, this will serve to drive innovation and customer benefit. And at the other end of the scale, I believe it will serve to eliminate from the marketplace some of the low-performing products which probably shouldn't be there. When you compare the new standard with the two existing dominant standards, it's easy to see that the new standard has taken the advantages from the existing standards and eliminated the disadvantages. Overall, this contributes to a much better testing procedure and classification system. One of the most significant advantages of the new standard is that it requires that filter efficiency must be measured against the fine particle fraction, so-called PM1. This is all particles which are sized less than 1 micron. And this test must be done on the new filter and repeated again when any electrostatic charge on the filter has been removed or dissipated. And this is because the presence of an electrostatic charge can artificially enhance performance in the laboratory. However, in real-world applications, electrostatic charges are lost and there is no addition to performance. Both the new result and the discharge result must both exceed 50% minimum efficiency before the filter can be classified as PM1. This is important because the medical and the scientific communities are increasingly reporting that it is the fine particles, the PM1 fraction, which are most hazardous to human health. Camfil strongly recommend the use of EPM1 rated filters to improve indoor air quality and improve human health.